to start this lesson, let's graph. And there's a lot to remember here while we graph. All right. Graphiel. That's his new name. All right. So I'm going to just rewrite it out here. 2x minus 5y. Are you really going to be laggy on me all day? All day. All right. There it is. Oh, I know what the problem is. Give me 1 second. I can fix this. Okay. It shouldn't lag anymore. Okay. So, that's the original problem. There it is. What we have is something that's not solved for y, so I have to solve it for y. What do I do first? Well, let's get rid of the 2x. We're going to subtract 2x minus 2x from both sides. Okay. By doing that, that crosses out. I can drop down the 5y is less than or equal to. And I'm going to write this out in a way that's slope-intercept-y. So I'm going to write out negative 2x plus 10. Is y all by itself now? No. What's in the way? Negative 5, negative 5, negative 5. Oh, looky there. I just divided by a negative. What does that mean? Well, up here, I'll write out what it means. Up here, I have y is greater than or equal to, because we divided by a negative, we flip the sign. Negative 2 over negative 5 is going to be positive 2 over positive 5. X, and then 10 divided by negative 5 is minus 2. Now let's graph this. Let's graphiel this. That'll never get old. I'm going to start at negative 2 and put a dot there. On the y-axis, of course. I'm going to go up 2, right 5, up 1, 2, right 1, 2, 3, 4, 5. I won't be able to do it again, but what I can do is go to my graph and go down 1, 2, left 1, 2, 3, 4, 5, and put a dot there. You see what I did? Up and to the right is the same as down and to the left. Now, before I just willy-nilly graph, take a look at the sign. See how that's greater than or equal to? See it? That means when you draw a line, you're allowed to fill that line in. If it was just greater than, we would make a dashed line. But not only is this greater than or equal to, it's greater than. What does that mean? I shade everything above the line. Listen, I'm not saying it looks good. It's just right. And the computer is just acting ridiculously slow today. That's all right. I don't need it. I don't need no stinking computers. I'm going to close a couple of my tabs. Maybe that'll help. Maybe that'll help. All right. What's the objective? That, kids, is from a television show called The Office. If you don't know what it is, watch it. It's literally the best show of all time. Give it a shot. I will be able to find the missing sides of a right triangle and simplify radicals. All right, so Pythagorean theorem, kids. Very, very, very old stuff. To find the missing sides of a right triangle, we are going to use a little thing called the Pythagorean theorem. Now, what's the Pythagorean theorem mean? Well, I have a right triangle. It has to be a right triangle. Otherwise, it won't work. It would be a wrong triangle. So the longest side, I'm always going to label C. This longest side is called hypotenuse. The longest side is always called the hypotenuse. The two shorter sides, doesn't matter which one's which. They're called legs. Call one of them A, call the other one B. It doesn't matter which one's which. So let me see. Once you label things out, you're going to use this little ditty right here called the Pythagorean Theorem, and that'll do some math. Oh, maybe I'll have a video that would show you how it's done so that you're not lost in the woods.
Pythagorean theorem. I have to find the missing side. Pythagorean theorem is this formula right here, which is used to find the missing sides of right triangles. Okay? C always represents the hypotenuse, also known as the longest side. So I can call you A, I can call you B, but I have to call you C. So I have 4 squared plus 3 squared equals x squared. 4 squared is 16, 3 squared is 9, x squared is x squared, 16 plus 9 is 25, 25 equals x squared. Now how do I get an x all by itself if it's being squared? Square rooted, of course. Now normally we would say positive or negative square root of 25, but since we're talking about a missing side, you can't have a negative length. So the square root of 25 is 5, x is 5 units long, whatever unit it's supposed to be.
All right, so basically, you take a bunch of Johns and you plug them into a bunch of Johns, and you square things. You either add or subtract depending on what you do, and then you square root things. So let me write out my John. This is called a John. Anything is a John. A squared plus B squared, that's my Pythagorean John. What I have to do is label my triangle over there. So I have C as C. C is always going to be the longest side. That's my hypotenuse. I'll call you A. I'll call you B. It really doesn't matter which one you call the legs as long as the longest side is C. If I called A squared, or if I called A 4, then I'm going to replace A with 4. So I have 4 squared, a fun game. And if I have 6 squared over here, or B, I'm off today. If I have B, which I'm calling 6, I'm going to replace the B with 6. And I don't know what C is, so C squared. 4 squared is 16. 6 squared is 36 equals C squared. So now that I've plugged things in, I'm just doing regular old math. Speaking of regular old math, 16 plus 36 is 52. That's going to equal C squared. Is C all by itself? No. What's in the way? A squared's in the way. How do I get rid of a square? The old square root, baby. I don't know what the square root of 52 is. I wonder if Siri does. Siri, what's the square root of 52? I do know it's bigger than 7 and smaller than 8. I found this on the web. Okay, I was talking way too much. Siri, what's the square root of 52? It's bigger than 7, smaller than 8.
I found this on the web.
Oh, you know what? It won't tell me. That's bizarre. Oh, yeah, it will. No, it won't. One more try. What is the square root of 52?
The square root of 52 is approximately 7.2111.
I don't know why it had to be ridiculous like that, but that's that. I don't have any units, no inches, no centimeters, no feet. So I'm just going to leave it as 7.2. And if I wanted to go above and beyond, I could say 7.2 units. But as the one girl says from the internet, ain't nobody, does not anybody have time for that. Oh, look, a right triangle. And when I'm trying to find the missing side of a right triangle, I have to do Pythagorean theorem. So A squared plus B squared equals C squared. I'm going to label my triangle. It doesn't matter what I label as long as I label the longest side C. So 21 is C. I'll call A X and I'll call B 15. So A is now X, X squared plus B is now 15, 15 squared equals C is now 21 squared. X squared is X squared. 15 squared is 225. 21 squared, I believe, is 421. What's 21 squared?
21 raised to the second power is 441.
All right. Is x all by itself? No. What's in the way? Well, I have a 225 that's along the side. So different from the last problem, instead of adding those two numbers, I have to subtract those two numbers because, you know, solving. That's the way solving be. 441 minus 225.
The answer is 216.
That's supposed to say 216. Is x all by itself? No. What's in the way? Squared. How do I get rid of squared? Do the opposite, which is square root it. The square root of 216 is not a pretty number. What's the square root of 216?
The square root of 216 is approximately 14.6969.
I'll just say 14.7. Hey, good job, gang. Good job, friends. The heck is this? Another video? Is it my birthday?
All right, find the missing height. We have ourselves a right triangle. Anytime you're trying to find the missing height of a right triangle, use Pythagorean theorem. Always make sure that C is the longest side. It doesn't matter which one is A or B as long as the longest side is C. So this is going to be 35 squared plus h squared equals 50 squared. 35 squared is 1,225. H squared is h squared. 50 squared is 2,500. Subtract 1,225 from both sides. When you do that, you end up with 1,275. Get rid of the squared, you have to square root both sides. When you do that, you get yourself, not too pleasant number, but it ends up working out 35.70 blah, 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 so we'll just leave it at that. So 35.7 feet.
Mr. Parrott, when are we going to ever use this in real life? Kids always say. Well, let's say you're golfing, right? And you're playing par 3 with your fam. And someone be like, hey, man, if I just hit the ball 120 yards that way and then hit it 70 yards that way, I can get the ball in the flag thing hole. Well, that's great. But then the smart kid in your family is like, which is you, you're like, well, if I could just hit the ball, I don't know how many yards. I could just get it in one shot. As Eminem said, you only get one shot. Well, let's see how many yards that would be. This over here, if I were to just shoot the ball right in the pin, if I were just to slam dunk that golf ball right into the hoop, how long would it take me? Or how far would I have to home run that ball into the hoop? So I'm going to call it C. Why? Because it's the longest side in a right triangle. I'll call you A because A and B doesn't really matter as long as the longest side is C. So I have A squared plus B squared equals C squared. A is 70 squared. B is 120 squared. C is, I don't know. If 7 squared is 49, then 70 squared is 49 with 2 zeros attached to it. And if 12 squared is 144, then 120 squared is 144 with 2 zeros attached to it equals C squared. $49 plus 144 is, let me think, 49, why am I blanking here? 192? No. Yeah, no, 193. Oh. Doesn't seem right, but I think it is. That's going to equal C squared. Is C all by itself? No. What is in the way? Squared. How do I get rid of its square root? Square root. What's the square root of 19,300?
The square root root of 19,300 is approximately 138.924.
Oh, 138.924. Let me erase. Oh no! Let me erase 138.924. So we'll just say 138.9. I didn't put units here, so we'll just leave it like that. Now, for whatever reason, I feel super insecure about my work. So let's have Siri do the job. I know if I'm doing Pythagorean theorem and I have both of my legs, I'm going to end up squaring the legs and then adding them. So 70 squared plus 120 squared.
The answer is 19,300.
Yeah, so even though I felt like I did it wrong, I actually did it right. Look at me. I'm a genius and I don't even know it. Ugh. Mr. Parrish. So when you guys yell at me saying, when are we going to use this stuff in real life, don't come knocking down my door when you get locked out of your house and the only way to get in is to get a ladder and get into the second floor. You're locked out of your house, and the only open window is on the second floor, 20 feet above the ground. Holy cow. You need to borrow a ladder from one of your neighbors. Well, you don't have your own ladder? Buy one. There's a bush along the edge of the house, so you'll have to place the ladder 15 feet from the house. Okay, so up here, so this ladder is 20 feet up in the air. There's a bush over here that's 15 feet away. What length of ladder do you need to reach the window? Finally, we get a nice answer. Finally. I have to find that. I'm going to call it C. Why? Because it's the longest side of a right triangle. So we have A squared plus B squared equals C squared. A squared is going to be 15. Oh, you know what? Nah, I didn't label it. Plus 20 squared equals C squared. 15 squared is 225. 20 squared is 400. That's going to equal C squared. What happens when you add those guys together? What happens when you add those Johns together? 625, baby. That's going to equal C squared. Is C all by itself? No. What's in the way? A squared. How do I get rid of that squared? Square root everything, of course. And the square root of 625 is 25. What are we talking about? Feet? 25 feet. Again, don't come knocking down my door when you get locked out of your house. A radical is, well, according to the Ninja Turtles, it's basically a way of saying, hey, man, this is great. But if you were to simplify a radical, if you were to not use a calculator, which I'm not going to use, this is what you do. And this is the Nick Parrish method of simplifying square roots. You need to make what's called a factor tree. You need to make what's called a factor tree. So, that's my breakfast. A factor tree is when you take your number and you think of all the numbers that multiply out to that number 96. So what multiplies out to 96? How about 2 and what is that? 48. Factor tree. What else? 48 is 6 and 8. Don't circle any of those because those are not prime. 3 is prime. 2 is prime. 8 could be 4 and 2. Circle it. And 4 is going to be 2 and 2. Circle those. So 96 is the same exact thing as 2 times 2 times 2 times 2 times 2 times 3. One more time for the people in the back. 96 is 2 times 2 times 2 times 2 times 2 times 3. So this is what I'm going to do. I'm going to rewrite out 96 to be 2 times 2 times 2 times 2 times 2 times 3. When you simplify a square root, you're looking for groups of 2. You're looking for pairs. You're looking for squares. Okay, 2 times 2 is a square. 2 times 2 is a square. 2 times 3 is leftovers. When you have, so this is the method that I use, the Nick Parrott method of simplifying square roots. Step 1, make a factor tree. Step 2, write them all out. Step 3, circle all the identical pairs. Step 4, pull out 1. So I'm going to bring out a 2. Pull out another 1. So I'm going to multiply another 2. What's left inside is a square root and 2 times 3. So what I did is 2 times 2 is 4 on the outside. On the inside, I have square root and 6. And that's how I simplify a radical. Let's do it again. I have the square root of 216. So I need to, step 1, make a factor tree. 216 is 2 and 108. Circle. 108 is what? 54 and 2. Circle. 54 is, what is that? 9? 9 and 6? 9 and 6. Don't circle. 9 is 3 and 3. Ugh. 6 is 2 and 3. There you have it. So 216 is writing in order 2 times 2 times 2 times 3 times 3 times 3. Circle all the identical pairs. You're an identical pair. 2 is not because it's left over. You're an identical pair. That 3 is not because that's left over. Bring out each identical pair, but only bring out one of them. If I bring out 1, 2, I have a 2. If I bring out 1, 3, I have a 3. And what do I have inside? 2 and 3. 2 times 3 is 6. Square root of 6. Dunzo. Algebra 1 stuff. Algebra 1. That all I have to do? Yeah. So let's do it again. Did I do 98 or did I do 96? I did 96. Ah, so close. All right, so again, the reason why we have to do all of these is because these are not perfect squares. If only we had the square root of 100. If only I would have given you square root of 81. Whatever, I don't have it. So I don't know what the square root of 98 is. So I'm going to make step 1 a factor tree. Again, thank you, lag. A factor tree is when I take a number and I write out all the prime factors for it. This gives me 49 and 2. I could circle 2, and 49 is, 7 and 7. This is actually going to be an easy one. So the square root of 98 is the same thing as 2 times 7 times 7. Circle every identical pair. That's the only one. Bring out one of them. Bring out 1, 7, and keep 1, 2. And that's my answer. If you're like, man, I just don't know if I'm doing these right, then what you do is you ask your phone what the square root of 98 is, and then ask your phone what 7 times the square root of 2 is, and if you get the same answer, by golly, you did it right. I don't know what the square root of 72 is. It's not a perfect square, but I know that 72 is 9 and 8. And I do know that 9 is 3 and 3. And I do know 8 is 2 and 4. And I do know 4 is 2 and 2. Which means the square root of 72 is the same thing as me writing this in order. Dos times dos times dos times tres times tres. I circle each identical pair. There's one. 2 is a leftover. And there's another one. I pull out one of each. So I bring out a 2. I bring out a 3. And I have 2 left over. 2 times 3 is 6. My leftover is 2. So as you get the hang of it, it goes a whole lot faster. It's just learning how to do the Nick Parrish way of doing things. And maybe what I need to do is just make a separate video called the Nick Parrish method of solving or simplifying radicals. And I'll call it the Nick Parrish radical method of simplifying radicals, dude. Cowabunga. You guys don't know what I'm talking about. Fun fact. Let's go back to a problem that we recently solved. This triangle here was, oh my gosh. This triangle here was, when I wrote it all out, 20, 15, and 25. There's a special triangle called the 3-4-5 triangle. It's called a Pythagorean theorem triple, or a Pythagorean triple, I mean, which means no matter what, all of those types of right triangles will simplify down to the easiest of right triangles, which is a 3-4-5. I may not see this right here, but I know what the answer is automatically: 3-4-5. This is a special type of triangle called the 3-4-5 triangle. As long as 5 is your hypotenuse and one of them is 3 or the other one is 4, that's what you're going to get. We'll talk about that later in geometry. We're going to go over several types of the Pythagorean triple triangles. Boy, try saying that fast 3 times. Pythagorean triple triangles. Pythagorean triple triangles. I'm scared. But that's that. Okay, that's the end of this video.